Good morning, everyone. Today we are going to see the topic that is overview of the systems from the subject digital signal processing, and myself Priyadashini, working as assistant professor at the EEE department of RMD Engineering College. So here, what is a system? A system, it is a process to be done on the input signal, or a kind of transformation is given to the input signal. So input signal, it's given to a system and we are getting an output signal, some kind of transformation. Transformation is nothing but some kind of a change is given to your input signal. So y of n is equal to capital T. The capital T stands for transformation of x of n. So y of n is equal to the output signal and x of n is the input signal. Major classification of the system is continuous time system and discrete time system. So here, the subclassification is common to both the types. So what are the subclassification? Static and dynamic, time variant and time invariant, causal and non-causal, linear and non-linear system, recursive and non-recursive, stable and unstable system. So first we are going to see the first classification, static and dynamics. What is a static system? A system is said to be static or memoryless if its output depends only on the present input, not on the past. That is, as a static system is generally a memoryless system. So generally, if it is a memoryless, means it is not depending on the past or the future, it is depending only on the present. So what is a dynamic system? A dynamic system, any system is said to be dynamic. That is, if the output depends on the present input as well as the past or the future, it is called as a dynamic. Example 1. Y of n is equal to x of n into x of n minus 1. So we have to find out whether it is a static system or a dynamic system. To find out the value, so we have to substitute the value for the n. So I am taking the value for the n is going to be 0. So y of 0 is equal to x of 0. And here, if I am substituting 0, I am getting x of minus 1. So from this itself, it is indicating x of minus 1, it is a past value. So it depends on the present as well as the past. So the system is said to be a dynamic system. So always, whenever they are giving in any problem, so we have to substitute the value n is equal to 0. So first is the next example, y of n is equal to x square of n plus x of n. So here I am taking the value of 1. Okay, so there initially we have did with the 0, no? So here I am taking the value of 1. So y of 1 is equal to x square of 1 plus x of 1. So it depends only on the present. So it is a static system. At this place, if I substitute 0 also, the value is not going to change. Y of 0, x square of 0 and plus x of 0. So it depends only on the present input. So this system is a static system. So another example is y of n is equal to x into 2n. So the two conditions we are going to take. The first is I'm doing it as 0. If I'm substituting a value n is equal to 0, y of 0 and x of 0. So it is acting as a static. Suppose I am taking the n is equal to 1. Y of 1 is equal to x into 2. So it depends on the future. So it is a dynamic system. So how to conclude this kind of problem is only for n is equal to 0, it is acting as a static system. For the remaining inputs, it is acting as a dynamic system. So when compared, so the dynamic system conditions are very high. So we can say this overall, the system is a dynamic system. So like this, you can give the conclusion. So the next statement or the next type is going to be time variant and a time invariant system. So what is time invariant system? Okay, generally. The system is said to be a time invariant. So TIV stands for time invariant. So the system is said to be time invariant if the characteristics or does not change with the time. That is, within the time, for a particular time, the characteristics of the system shouldn't change. Okay. So what is a time variant system? If the characteristic changes with respect to the time, is called as a time variant system. So the conditions are y of n comma k, a small sample has been shifted out. N comma k is equal to transformation of x of n minus k. Okay, so this is going to be a time invariant system. Example, y of n is equal to x of n plus x of n minus 1. If the input is delayed by k units. Okay, so if the input is delayed by k units means, so that x of n has to be subtracted by k from. So x of n minus k plus x of n minus k minus 1. And if the output delayed is response, so that is the response itself is getting delayed. So n has to be replaced by n minus k. So y of n minus k is equal to x of n minus k plus x of n minus k minus 1. So here the both conditions are same. So this is called as what? Time invariant system. And similarly, we can take another example that y of n is equal to x of minus n. So here, if the input is delayed by k units, this minus n is subtracted by minus k. Okay. But if the output response is getting delayed, means y of n minus k is equal to the overall values is replaced by n minus k. So it is minus, that is minus of minus will become plus. So both the equations are not same. So this is called as what? Time variant system. So similarly, we can do it for another example. Y of n is equal to x of 2n. So here also, just to see that x of 2n minus k, and here the n is replaced by n minus k, means the values are not same. So this is also a time variant system. So the next example is y of n is equal to x square of n minus 1. If the input is delayed by k units, so n minus 1 minus k. And similarly, the response itself is getting delayed. So overall, this that is x square of n minus k minus 1. So the system is a time invariant system. So similarly, we can do with this also x of n by 2. So for this x of n by 2, it is acting as a time variant system. Okay. The last example is y of n is equal to n into x square of n. So here the n value has been given like this. So here the input is delayed by k units, means I will be getting that first this n x square of n minus k. But the overall response is getting delayed, means n minus k x square of n minus k. So the both are not same. It is called a time variant system. The next is going to be a causal or a non-causal system. If the system depends only on the present and the past input, but does not depends on the future, means it is called as a causal. What is non-causal? If the output depends on the future alone, is called as a non-causal. Example, y of n is equal to x of n minus x of n minus 2. So if I substitute the value, so I'm going to take the values of 0, 1 and minus 1. If n is equal to 0, y of 0 is equal to x of 0 minus x of 0 minus 2. It depends on the present as well as the past input. And similarly, if I'm taking n is equal to 1, y of 1 is equal to x of 1 minus x of 1 minus 2. It depends on the present as well as the past input. And here, if I'm taking the minus 1, it depends on the present and the past. So it is a causal system. So for all the three conditions, we have to satisfy that it has to be depend only on the present and the past. So the system is a causal system. But for the second example, y of n is equal to n of x of n. So here, if I substitute all the three values, 0, 1, and minus 1, the output depends only on the present input. And here for the one, it depends on the present input, and here the output only on the present input. So the system is a causal system. Okay. And what about this condition? So here the last example is y of n is equal to x of n plus 2x of n plus 3. If I substitute the values for all the three conditions, 0, 1, and minus 1. So here x of 0 plus 2, x of 0 plus 3, the output depends on the present input as well as the future input. And here also the next value also is coming like this. So it is not a causal system, it is a non-causal system. So causal means it has to be depends only on the present and the past. If it is depending on the future, it is a non-causal system. The example, y of n is equal to x of 3 into n. So here itself, the 3, that value is coming as a 3 into n. So whatever the value we have to substitute for the n, it has to be multiplied by 3. For example, if n is equal to 0, 3 into 0 is equal to 0. If n is equal to 1, 3 into 1 into 3. If n is equal to minus 1, 3 into minus 1 is so minus 3. So it depends on the present, it depends on the future, as well as it depends on the past. So it is a non-causal system. The next system is going to be a linear and a non-linear system. So what is a linear system? The response of the sum of the weighted input is equal to the sum of the weighted response. Okay. If the condition is not satisfied, it is a non-linear system. The linearity equation is the transformation of a1 x1 of n plus a2 x2 of n is equal to a1 transformation of x1 of n plus a2 transformation of x2 of n, and a1 and a2 are the arbitrary constants. So generally we can represent with this diagram also. So if I'm giving two different inputs, x1 of t and x2 of t, if it is added together and my final transformation is like this. And here I'm doing the transformation initially and then I'm adding together. So both the things has to be same. So this is nothing but our superposition principle only. That is, initially we are doing separately, and then that is, we are giving two inputs and we are getting the overall transformation. But here we are doing the transformation separately and then we are adding together. If both are same, it is called as what? Linear system. So today, the first example we are going to see on the linear system is y of n is equal to x square of n. So we have to find out this is a linear or a non-linear system. Okay. So first is the output due to the weighted sum of the inputs. Y3 of n is equal to x3 square n. So what we know, what are the values? A1 x1 of n plus A2 x2 of n the whole square. You substitute the value, my y3 of n is this. And linear combination of the two outputs. So we have to add it together. A1 y1 of n plus A2 y2 of n. If I substitute, both the values are not same. So it is called as a non-linear system. So check the linearity for the given system. So here y of n is equal to xn square. So y1 of n. So we have to do it for the separate inputs, right? So y1 of n is equal to x1 n square plus y2 of n is equal to x2 n square. If I am adding both the things, my final answer is a1 x1 n square plus a2 x2 n square. The linear combination of the outputs is y3 of n is equal to a1 y1 of n plus a2 y2 of n. If I add it together, if 1 is equal to 2, the system is said to be a linear system. Okay. The last is going to be recursive and non-recursive system. The recursive system, if the system output depends on the number of the past output and the present and the past input, okay, means it is called as a recursive system. Non-recursive system is if the system output depends on the present and the past input alone, it is called as a non-recursive system. What is a stable and unstable system? So generally a stable is if the bounded input is giving, it should produce a bounded output. An unstable system is if the output is not bounded, it is called as a recursive and that is unstable system. Okay. Thank you.